a new chapter called chemical bonding. So you have done little bit of chemical bonding in school. So we'll try to revise it again. Okay. So what is a chemical bonding? Please write down. Right. Name of the chapter is chemical bonding and molecular structure. Chemical bonding and molecular structure. Right. The attractive force. The attractive force which holds together the constituent particles then within bracket please write atoms, molecules. You have written attractive force which holds together the constituent particles.
Yes, sir.
Within bracket you write atoms, within bracket, comma, molecules or ions. Close the bracket. In a chemical species, is known as chemical bond. Okay. Then write next paragraph. The tendency of elements to combine with one another is directly related to the valency of the element. Then what is valency? Valency is the ability or tendency to tendency of the elements. Elements to combine with one another. Okay. Cause of chemical combination. Okay, now we'll discuss. First, you write up to this one, then I'll tell you.
Sir, done.
Let me see what about your other friends.
Sir, done.
Hmm.
Done, sir.
Done.
Okay, good. Then, why should they combine? This decrease in energy. See, any relationship bring happiness to us. Everything in this universe, they wants to come down to the lower energy state. Okay, everything, because of that, when it rains, water falls on the ground. When water gets accumulated in higher mountain, it rolls down and reaches sea. Huh? So everything they want to come down to a state of lower potential energy. So we find a free atom is not stable. So free atom combines with other, by that way its energy decreases and it attains stability. Okay. So please write. Write this one, then write this one. Then we'll write 1 and 2 sentences. I just tell you and you write it. Written.
Sir.
Okay. Acha, when I talk to you, can you hear me clearly?
Yes, sir.
Okay, then please write now. Below this you write. It is a fundamental truth that all natural systems tend to lose T and D tend to lose potential energy and become
Sir, can you
more.
please pardon?
It is a fundamental truth. All natural systems tend to lose potential energy and become more stable. Full stop. This is due to the fact that the bonded state has.
Sir, can you repeat again?
This is due to the fact that bonded state has lower potential energy than unbonded state. Stop. Hence, when two atoms approach each other, they combine only under the condition that
Sir, can you repeat?
when two atoms approach each other, comma, they combine only under the condition that there is a decrease in potential energy. There is a decrease in potential energy. Okay, so this is the first condition. So chemical bond always brings stability, and by that way, the potential energy of the individual atom decreases when they bind with other, and it comes down to the lower energy state. Okay. Second is Lewis octet rule. Lewis octet rule. We'll write now. Okay, this one I'm going to write because if I tell you, somehow you are not able to understand my English. Maybe it's very, very poor. The noble gases are known for their lack of chemical reactivity. It is because of their completely filled valence shell electronic configuration. What is that, dear? It is NS2 and P6. And attain minimum energy state. Therefore, atoms of all elements when enter into chemical combination try to attain noble gas or octet octet configuration. This tendency of atoms to achieve eight electrons in their outermost or valence shell is known as Lewis octet. Lewis octet.
Sir, done.
Sir, done.
Sir, done.
Why they want to form chemical bond?
Yeah.
First of all, that they want to come down to the lower energy state. And how they can come to the lower energy state? Only when in the outermost shell, they can have 8 electrons. So see, out of 118 elements, only 8 elements have, not 8, 7 of them has 8 electrons in the valence shell, and 1 of them has 2, that is helium. And from neon up to radon, they have 8 elements. Okay, that is 118 minus 8 is 110. This all these 110 elements, they do not have 8 electrons in its outermost shell. But in individual capacity, their energy is very high. So they always want to attain the more stability. And how they can go for the more stability? It is only possible when they can put 8 electrons in its valence shell. So the 8 electrons in the valence shell can be done by 2 processes. One, either by loss or gain of electrons. When they go for loss or gain of electrons, in such case, they either form cation or from anion. And this, if they lose electron, someone else have to take it. And if they wish to have electrons, then they have to get it from others. In this case, you'll find both the species who have lost or gained electron, they achieve the ionic state. In that case, they are going to form a mutual relationship. And that is we are going to discuss later on is we call it ionic bonding. And in some cases, it is not possible to gain or lose electron because every atom has different limitations. Some atom, if they wish to release the electron, they find it is not possible because the electrons are held on the valence shell with a very strong force. All right. So in that case, what they'll do? In that case, they will have to share the electron. I do not know whether some of you have ever walked on the railway lines. Is it not? Railway lines, they do not meet each other. So in our childhood, we used to, by the side of our place we used to stay, railway lines were there. All right. If the railway lines are there, and we used to walk. We used to see, can we balance? After walking, after some time, we used to somehow fall down. But if you are here and if your friend is here, and if you hold your hand each other, you can walk miles together. In that case, what you have done? Each of you have exchanged energy and make yourself stable. Once one of them removes the hand, the other will fall down. That is called covalent bonding. Okay? So the best thing to stay happy in this world, in a family or in a society, okay? Try to always respect and love your family members and your neighbors. That way, your tension or potential will be less and you will lead a happy life with a very good relationship. You cannot stay with your neighbors by threatening every day with a pistol. Huh? Okay. Now we know what is Lewis structure. We know you have done in the school. In Lewis structure, what you do? We try to indicate the number of electrons with some dot. Is it not? Try to so as many number of the electrons we have in the outermost shell and valence shell, we try to project it or show it with the help of a dot. Each dot indicates an electron, and that structure is called Lewis dot structure. All right. Please write down. Electronic theory of valency.
So is that point number 3?
No. It is a separate heading. See, every theory and assumption, every theory initially starts with an assumption. So, and these assumptions are nothing but the basis of the theory. Electronic theory of valency. Okay? Or you call it is octet. Or who proposed it? Or we call it Cosel. See, always we mention this Lewis, but he is also a person to be involved in this theory. Cosel Lewis. approach to chemical bonding. They are the pioneer person who has done work on the chemical bonding. Okay. Right here, the main postulates means assumption of electronic theory of valency R. One. The valence of an atom depends mainly on the number of electrons present in the outermost orbit. These electrons are termed, T-E-R-M-E-D, termed as valence electrons. Second, electronic configuration of noble gases is stable. That is, presence of 8 electrons in valence shell brings stability in the electronic configuration in an atom. Now I'm feeling cold. Third, atoms having less than 8 electrons in the outermost shell are chemically active. The tendency of these atoms is to achieve achieve 8 electrons in the outermost shell. The number of electrons which take part in achieving octet determine the valency of the is very simple. Suppose if they have 7 electrons, they want to achieve octet, they require 1. So valency of that atom is 1. If they take 2, then it is 2. If it is 3, the valency is 3, like that. All these things we know. The only thing that I am putting in black and white.
Sir, done.
Okay. Then 4. There are 2 ways by which atoms can acquire noble gas configuration in their valence shell or outermost shell. A. By losing or gaining electrons. Second, by sharing electrons. So they can do by two methods. Either they lose or gain, or they share. Okay. How they can get now? Let us see. A. By losing or gaining electrons. In the periodic table, the highly electronegative elements and highly electropositive elements are separated by noble relation. See, this theory was based on Mendel's periodic table. So here I will not like to comment anything. This is a very, very old theory. Acha. So this is A. Okay. So this is 1. Second. The formation of negative ion and positive ion of the elements is associated with with, see, when negative ion, that is the gain, or loss of electrons. The negative and positive ions thus form. Thus formed Jolkha. Noble gas electronic configuration. The negative and positive ions are stabilized. Negative and positive ions are stabilized by electrostatic attraction. Electrostatic attraction. So this is the theory of formation of ionic compound. So let me show you with this structure. See, according to the Lewis concept or electron dot model, we only put a dot for the valence electron. So if I have taken sodium, okay, sodium we know 1s2, 2s2, 2p6, 3s1. So this is the valence shell. Last. And chlorine. See, those days this concept of electronic configuration is not there. Now we know. 1s2, 2s2, 2p6, 3s2, 3p5. This is the valence shell. Now see here. In this case, one electron is extra to the octet configuration. And in this case is one electron short of the octet configuration. Okay? So in this case, sodium is going to lose and the chlorine is going to gain. Huh? And why? Because sodium is electropositive, they have a tendency to lose electron, and chlorine is electronegative, they have a tendency to gain electron. So those days, it was difficult for people to know all this. Now we know. So what I'll write now here? I'll write. I'll put one dot here. And what I'll write now here? Minus E. So what I'm going to write here? Na plus. And chlorine. 1, 2, 3, 4, 5, 6, 7. So what I'm going to write now here? Acha, now see. I'm going to here this 8 electrons I'm going to put. Okay, I'll put it here. 1, 2, 3, 4, 5, 6, 7, 8. See, now it has attained octet. So it has lost and is going to gain. So what I'll write now here? 1, 2, 3, 4, 5, 6, 7, 8. So this has attained octet. This also attained octet. Right here, CL. So they have formed sodium ion and chloride. So they have to stabilize themselves. How they stabilize? These will be attraction between positive and negative. So how what I'm going to write here now? See, they are going to remain side by side. They have a attraction. What is the attraction? This is called electrostatic force of attraction. Okay. Or we call it Coulombic force. CO L-O-U. Coulombic force. I don't know, my spelling may be wrong also. Is this spelling always I forget? COLOUM. HT is all right. Coulombic force. Kita sama kita tanda lagi ni, betul betul ni, eh? So here we have discussed about the relationship which is being made by the loss and the gain of electrons. When a species an atom lose electron, it forms cation. When an atom gain electron, it forms anion. And these cations and anions, they remain side by side through an electrostatic forces of attraction. And this we call it later on ionic bonding. But actually they do not bond means a relationship. So we do not have any one-to-one relationship. They only stay nearer to each other to neutralize their charges. Then we'll go for the next mode. It's called B, sharing of electrons. Okay, sharing of electrons. Let me write here. Sharing of electrons may be of two types. Equal contribution of electrons is made by maybe two atoms and these are then shared equally in the formation of now of covalent bond.
So done.
Okay. So in this case, if one electron is given by if one electron of each is being shared by the two atoms, then you get a single bond. And if it is more, then we get more than one bond. All right. So in that case, suppose I have taken here Cl. Say it is this. See, it is having 7. Then what is going to happen? In this case, you will find it is having 7 and it is having 7. We know that the elements on the right hand side of the periodic table, they have very high ionization enthalpy. say they do not like to lose electrons. They always like to gain electrons. But where from they'll gain electrons? If they find someone who is kind enough to give. But we have taken both of them chlorine. So they do not like to lose any electron with each other. Then in that case, what you will do? They have to share. Okay, this is the one. See here. See this. In this case, they share. Now you count the number of electrons. 2 plus 2 plus 2, 6 plus 2, 8. And it is 2 plus 2 plus 2, 6 plus 2, 8. All right. So you get this one. So in that case, how we are going to indicate this one? This is being indicated by putting a bond here. Each bond has 2 electrons and we call them as bond pair. Now, these are the other electrons I'm writing like this. Right. Okay. So instead of drawing this one, you can also draw in this way. This. So this is the one which is being shared. All right. So what we are going to get here, we'll write like this is the way to express a covalent bond by Lewis electron dot model. So this is for a single bond. But it may happen that the atom may share more than one electron. All right, either with the same or with the different. So let us see if they share with the same element, what is going to happen. So it is oxygen. Oxygen has 6 valence shell electrons. It is 1, 2, 5, sorry, 3, 4, 5, 6. This thing all of you know it. Unnecessary time pass. So they are going to share because it is short of 2 in octet. It is also short of 2 in octet. So what you get now here? So it is 2 here, 2 here, 2, 2, 2. So you get here. So what I should write now here? So in that case, all right. Now they may not share with the same element. In this case, what you are going to get? 1, 2, 3, 4, 5, 6. Hydrogen. So what you are going to get now here? Hydrogen, oxygen, hydrogen. See here. This is water. So you are having single bond, and here you are getting double bond. Okay. Now, nitrogen. Nitrogen has 5 electrons in valence shell. So what you are going to get here? So this nitrogen you will get. That is, I can write here nitrogen is see here 6 plus 2 8, 6 plus 2 8. So this is what I'm putting. These 3 lines means equivalent structure. Okay, so this is the way we can do it. But mind you one thing: no two elements can have more than 3 bonds within themselves. Why it is not possible? Because theoretically it is possible. 4 plus 4 become 8. Why it is not possible? Because in this case the 2 atoms come so close with each other, both the nuclei repel severely. Okay, nuclear repulsion is the greatest repulsion. All right. Because of that, you cannot put one hydrogen atom inside the another hydrogen atom. They can share. You cannot put one hydrogen atom inside the another hydrogen atom. Okay. The reason is that yes, theoretically it is possible, but you have to supply that much amount of energy, and that type of energy is not possible to create on the surface of the earth. Okay, it happens in the surface of the sun. On the concept of this, people have developed nuclear bomb. So now this type of thing, हम क्या बोलेगा और? This type of structures you practice, huh? Okay. So now what should I write? Okay. NH3. So we know this is nitrogen. 1, 2, 3, 4, 5. So this is the structure of ammonia. So all this structure you please do. Okay, now I'll go for carbon. See, this is for CH4. Carbon has 4 electrons. 1, 2, 3. Hydrogen has 1 electron. This. So this is the structure of methane. If you don't want to draw a circle, what you have to write here? 2, 2, 2, and 2. Now if you want to draw for carbon dioxide, carbon has 4 electrons and oxygen has 6 electrons. This is for carbon dioxide.
আবার করেছে, আবার করেছে। গোড়া ছেলে এটা ছিল গ্লাইনি আর কি বলতে।
So done.
Okay. Okay, now here what did you find? That both the atom has given 1 electron each, or 2 electrons, or 3 electrons, like that. Second, where you find out of the 2 atom, one atom is giving the pair of electron and other comes without electron. So we'll write now. This is the second. Contribution of an electron pair by one atom and then both the electrons are shared equally. Shared equally by 2 atoms. Which result coordinate. No, these days you do not write with hyphen. Coordinate covalent bonding. Okay. So let's see. I have taken here NH3 and to that I have added acid H plus. This hydrogen does not have an electron. And what does it form? It forms NH4 plus. So let us see now. See, now we know see here, in this case nitrogen and hydrogen, the bond, hydrogen has given 1 electron, nitrogen has given 1 electron. So this is a covalent bond. Okay. And here this hydrogen has come without electron, without. A hydrogen without electron, we call it proton. Why do you call it proton? Because hydrogen has 1 electron and 1 proton. If the electron is not there, only proton is there. Because of that, H plus is also called proton. All right. So I'm going to write it as like hydrogen without electron. So in that case, what is going to happen? See here. Look, in the orbit of nitrogen, 2 electrons are there. In this case, hydrogen has 1 and nitrogen has 1. Hydrogen has 1, nitrogen has 1. Hydrogen has 1 and nitrogen is 1. And in this case, the 4 hydrogen does not have any. So see here, this is a difference. So this type of bonding is shown as called as coordinate bonding. Earlier, how we used to show you this one, you know, we used to show it like this, and this is being shown with an arrow, means to indicate that this hydrogen did not contribute any electron to the in the bonding. You have seen, no, that people have bought a car by taking loan from bank. So in that case, you'll find the car, it is written, this car is hypothecated to the name of that bank will be given. So everybody will know that this fellow did not have money to buy the car and he has taken loan. So this type of bond, coordinate bonds, are also called dative bond, D-A-T-I-V-E, dative. This word is not being used these days. Why? Because once the formation of the bond has taken place, you will not be able to identify which hydrogen did not take electron, because all 4 hydrogen, they behave similarly. So initially, when we studied in class 11 or 12, we used to call this bond as dative bond, means bond formed by donation, dative bond.
So done.
Done. Up to this much is okay. Then after that, I will take electron, because if I start, then I'm going to take half an hour. You might have classes and all this thing. So I don't mind taking the class, but it may hamper your school classes. So goodbye.
Thank
As
you,
a by the
sir.
by, in the group have
Sir.
all of you paid the fees for September? All of you?
Yes, sir.
Yes, sir.
Okay. Okay.
Thank you, sir.
Thank you, sir.
Welcome. Welcome. সিম্বাসিসে তো 21 তারিখে ক্লাস শুরু হওয়ার কথা, জানি না আমার ক্লাসে কিছু তো জানাইলো না, তারা না জানাইলে আমি ফোন করতাম না। আমার তো সাবান লাগবে না, আলাদা আলাদা